Okay, everybody, now that we're getting really good at solving linear equations, we're going to take a look at solutions of special linear equations, okay? So if you're looking at this table, it's telling you, oh, we can have one solution. Yeah, that's what we've been doing. X equals 4, n equals 5. Great. But what about no solution and what about infinitely many solutions? We haven't really looked at that yet, so we need to figure out what's going on. Now, for the sake of one solution, that's what we've been doing, and we're going to try this example. So 10k plus 7 equals negative 3 minus 10k. If we follow our steps, simplified on the left, simplified on the right. So we're going to bring all the variables to one side, all of the numbers to the other. I'm going to try to keep my variables positive, so I'm going to add 10k, and I'm going to add 10k. That guy will cancel. If I bring my equal sign down, I'm just going to have my negative 3. 10k plus 10k is 20k plus 7. Now I got all of my variables on the left, so I have to move all of my numbers over to the right. So I'm going to minus 7, minus 7. That's going to go away. Over on the left, I'm just going to have 20k, and I'm going to move it up to here because I'm running out of room. Over on the right, I'm going to have negative 3 minus 7, which is negative 10. Then last but not least, I have to get rid of the 20. So 20 times k, the opposite would be to divide. So we're going to have k equals, and then a negative divided by a positive is in fact a negative, and then 10/20 is actually going to simplify by 10, which is going to give me 10 divided by 10, and actually that's a negative, so negative 10 excuse me, divided by 10 is negative 1. 20 divided by 10 is 2, negative 1/2. This is an example of one solution. This is what you've been doing. K equals negative 1/2. Your one solution that satisfies that equation is negative 1/2. So let's take a look at what no solution would look like. 4 times 3k minus 1 equals 12d. So first of all, simplify the left. I'm going to distribute my 4. So 4 times 3k is 12k. 4 times negative 1 minus 4 equals 12d. Now, I just realized I have a typo in the notes. This is a k, this is a d, that is a problem. So, real quick, everybody go back to your notes, change this to a d. Change this to a d. Whoops. Okay, now that we have that problem fixed, our variables should match. If they don't, we have an even bigger problem. I'm going to try to get all my variables to one side, all of my numbers to the other. Now, both of these are positive, so you can really do whatever you want. I'm going to subtract 12d. I'm going to subtract 12d. Those are going to cancel. On the left over here, I'm going to have a negative 4, so I'm going to rewrite it over here. Equals, and then 12d minus 12d. What are you thinking? Well, that's 0. They cancel. So now let's look at what we're looking at. Negative 4 equals 0. Just repeat that in your head a little bit and ask yourself the question, does negative 4 equal 0? Does negative 4 ever equal 0? This is not true. And it's not true ever. Okay, negative 4 never equals 0. So if you get a statement while you're solving of negative 4 equals 0 or 5 equals 10 or something that's just you're going, no, that's not right, you have no solution. There is no answer or no number that we can substitute back into this that would make this statement true. It can't happen. Okay, last but not least, infinitely many solutions. First of all, okay, I didn't screw this one up. So let's try 21 minus 7w. Okay, that's simplified, we're good. But this one, we're going to have to distribute. So I'm going to copy down my 21 minus 7w equals, and then I'm going to distribute. 7 times 3 is 21. 7 times negative w is minus 7w. Now, at this point, you can kind of already start to see the infinitely many solutions if you do see it, but I'm going to take it a couple steps further and work this. So I'm going to get all of my variables on one side, all of my numbers on the other. So add 7w, add 7w. These guys will cancel. Bring down my 21 equals, bring down my 21, and negative 7w plus 7w also cancel. Now look at this statement. 21 equals 21. Is that true? I mean, up in this box we had negative 4 equals 0. That's not true ever. But this is true always. This is true all the time, no matter what. Which means this is infinitely many solutions. I can pick any number I want. 4, 5, 6, 7, 1/2, negative 2/3, anything I want. Then when I substitute it back into this original equation, it will work. And where I really started to see that was in this second step, where I had 21 minus 7w equals 21 minus 7w. Whatever I put in for w is going to make minus 7w the same thing. So right here in this step, I knew it was going to be infinitely many solutions, but when you take it even further and you get this true statement, definitely infinitely many solutions. Okay, we have 2 examples of that to try. So number 2, letter A, solve each equation, and we're either going for our typical one solution or our new no solution or infinitely many solutions. Let's see what happens here. So left side of the equation, I'm going to start by simplifying. 4 times 1 is 4. 4 times negative p is negative 4p equals negative 4p plus 4. Now, I'm looking at that going, they look very similar, but I'm still not sure, so I'm going to take it a step further. If I get all my variables on one side, I'm going to add 4p. I'm going to add 4p. Remember, if you do it to the left, you have to do it to the right. Negative 4p plus 4p, they're going to cancel. I still have my equal sign, which leaves me with a 4. Negative 4p plus 4p, those are going to cancel, which leaves me with a 4. 4 equals 4. Always true. This is always true. 4 always equals 4, unless we're on some weird alien planet. I don't know. So infinite solutions. Okay? You can pick any number you want. Any number. Substitute it back in, and it's going to work. Letter B. 6m minus m equals 5/6 times 6m minus 10. Okay, let's take a look at this. So first of all, on the left, 6m minus m. That's 6 of the m's minus 1 of the m's. We can simplify that to 5m's equals 5/6 times 6. Now, once again, some of us can do this in our heads, but it does get a little funny, and I don't really want to mess with it, so I'm going to grab my calculator. I'm going to take 5 divided by 6, and then out to the side, times 6. Again, don't put the variable on there. That would just make things confusing, and I don't even think this calculator does that. Hit your blue enter button. That's 5. Okay, back over. So 5/6 times 6n is just going to be 5m. Then we're going to take 5/6 times negative 10. Again, I don't really want to deal with this. So 5 divided by 6 out to the side times negative 10. Now, do you guys notice this is like a weird decimal and it doesn't terminate? You cannot use a non-terminating decimal in what you're doing. So I'm going to hit this little button right here. Oh, look at that. It converts it to a nice fraction. That's what I want. So 5/6 times negative 10 is negative 25/3. So this is negative 25 thirds. Don't freak out. It's not that big of a deal. Here's why it's not that big of a deal. I'm going to get all my variables over here to the left. So this is a positive 5n, m. I'm going to subtract 5m. These guys will cancel, which is going to leave me with this really nasty fraction. But 5m minus 5m also going to cancel and leave me 0. Now take a look at that. Does 0 equal a really nasty fraction? I don't care what the nasty fraction is, but does 0 equal negative 25 thirds? No, never. 0 equals 0. That's it. So this is not true. No solution. There is no answer that you can substitute back into that equation that will make it true.